Hi, welcome to lecture 18 for COMP1020. Um, Today we're mostly going to talk about user interfaces, and I'm going to talk about them in general and then look a little bit more about how we can make a basic user interface here in Python. And again, we're just kind of getting started with this, and don't feel too worried if some of this stuff seems like it's going to need some practice to be a little more familiar. We'll get there. Before we start that, next week on Thursday is our second midterm. Tuesday is going to be a review for the test, and we did that like kind of Kahoot stuff before. I guess I'll try to do a Zoom Kahoot and record it so that people can see it after it happens. And then there'll be some other review kind of stuff available as well. This is a new sort of setup for tests for us, so the form of the test is still a little undecided, although both the classes I'm teaching have a test next week, so I need to kind of pull the trigger and make a decision soon. As we're kind of figuring out the best ways to do this, I think this test will be some sort of Canvas quiz, just a little longer than, a little 2-question Canvas quiz. And it'll have different question types, probably some multiple choice type ones, fill in the blank from some large bank of questions. So you may not all exactly see the same test, and then some slightly longer answer. But the hard part is going to figure out some of the sort of, I don't know, like anything that might, well, anyway, we're working on it. My hope is that the test will be available for some fairly large window of time, and that when you take it, then you have so you can start over some large stretch of time, and then you have some very reasonable amount of time to actually take the test when you take it. I'm still looking at Canvas options there to see exactly what I can get away with. I've already heard from one person who will be flying internationally during the test, and you should get in touch with me if you can see a conflict for next Thursday. And then, of course, tomorrow is our first lab, and again, I'm trying to reformat the lab so you can do it on your own, but also there are 2 Zoom virtual lab sections available at 10 at 2, and look on the schedule. We'll post links kind of close to the start time where you can get a little bit of a more traditional lab experience. So either of those are fine, depending on how easy or hard it is for you to get access to, computers at the exact time you need it. Okay, so certainly feel free to ask questions on Piazza or something if you want, but maybe hold off a little bit on the test stuff. I don't have all the answers right now, and I'll be figuring those out and give you plenty of time to think about it. So we talk about user interfaces, and of course, a danger of user interfaces is that you can learn a little bit about user interfaces and make a lot of very bad user interfaces that way. So this one here, this picture, is actually a legitimate application you can get. It's for doing operations on files, and essentially it's trying to match all the power you can get by typing commands on the command line with a bunch of little boxes and check boxes and stuff like that. So this kind of thing that's, again, good for professionals, maybe even not that good. But I want to give some guidance as to sort of some generally accepted practice for user interfaces. And I think if you do any coding, you should kind of try to keep this stuff in mind. So a lot of this is based on a fairly influential book called The Design of Everyday Things. Donald Norman, he worked at Apple for a while and other places. And he has, it's a fun book to read. It has a lot of little anecdotes and stuff like that. It's not all about computer design. I think I sneezed last lecture too. But like the only 2 sneezes I've had in a week. All right. Maybe it's sitting down here in the basements and that is triggering something. And he has some principles that you can kind of think about when you look at interfaces. And so I want to just go over some of these kind of interfaces. So, for example, one principle is visibility. You need to let important things be visible and understood. And if you're looking at this is the car dash. It looks similar to, well, a lot of cars of 20 years ago. Now they're all mostly digital, but some still look like this just with pictures instead of physical dials. Um, you used to see this kind of stuff a lot, and essentially, it looked kind of cool. Those little needles were twitching around and stuff like that. But one flaw of this kind of thing is these two things look pretty similar to each other, and one is the speed, and the other one is revolution, the RPMs, how fast the engine's going. And if this was like a new car, you get adapted to it. You become a professional of your own car pretty fast, so it doesn't really confuse you for very long. But if it's a rental car or some friend's car or something like that, this kind of thing can confuse you and actually be dangerous, right? You might be driving 55 miles an hour in a 35-mile-an-hour zone or something like that, and both be unsafe or get a ticket. So you should think about how you're presenting information and make sure what you're presenting is actually well understood. Here's a more modern example. It's a Nissan Leaf. I have a used Leaf. It's a nice electric car if anybody's interested. It's equally bad. So it has these areas over here. So I'll draw, I guess, if I can. So we have this side and we have this side here, and they look kind of the same. And in fact, this side over here is telling you about your charge, your battery charge. And this side over here, which takes up an equally giant part of the screen, it's totally unimportant. It's basically the battery temperature. And I've never found any reason to care about the battery temperature. I mean, it does matter if you're in some extreme climate, but they just thought it looked cool because it was balanced, but it was not a useful kind of design, right? So be careful just throwing stuff in there just to kind of satisfy some sense of symmetry or something like that. The visibility of something should invite action somehow. So, for example, here are two apps, maybe on your phone or just a web page kind of thing. And what's sometimes unclear in web pages is, is this something that's a header or is it a link? And of course, the color makes you think it's a link, and so maybe you click on it. But if you really want to click on it, you should maybe make it look like a button, right? You want to invite action by telling people what kind of thing is expected for you to do with it. Buttons are things to be pressed. Text or something is just something to look at. So anyway, whatever you're showing should somehow tell you how you should interact with it. Now, an important part of all this is that you want to provide to people a good conceptual model of what your application does. And otherwise, people do kind of random things. And if you look at maybe a parent or grandparent of yours trying to work with a computer, and they do what seems to be, to you, inexplicable kind of things, it's mostly because whatever model they have in their head of what's going on is not either accurate or sort of non-existent, and so they don't see cause and effect of what they're doing. And when you're writing an application, you should make sure the cause and effect are very clear. A sort of classic example of this is if you look at a refrigerator, there's usually a dial for like how cold the refrigerator part should be and a dial for how cold the freezer part should be. But the problem is it doesn't actually give you the right model. So here's an example. Here's the freezer up here. Here's the fridge. And sometimes they have like A, B, C, D, and you have to go look and see what, is A cold or warm. You don't know. You have to go look it up or something. But the model in your head is probably something like there are two cooling units, and you basically dial in how much power you want to give to each unit. So you crank this thing up and this cools down, and you turn this thing the other way and this thing heats up, but they're basically independent of each other. The problem is that the actual engineering of a refrigerator is different. There's like one cooling unit, and there's like a baffle basically sending cold air up to the freezer and up to the fridge. And if you turn the one dial, it basically makes the whole thing go stronger. And then you turn the other one, and it kind of says which share goes to which part. So each of these, if you change this, it changes the overall temperature here because you're stealing cold air from here and putting it down here. And this one, if you change it, it cools everything. So this gets colder and this gets colder. And so, you can be very frustrated. Not that I have ever really adjusted my refrigerator temperature, but you can get frustrated in the sense that you change the refrigerator, and all of a sudden your freezer starts to thaw out, and you don't understand why. And that's because the controls they give are not a good conceptual model. They might even be labeled wrong. They might even say freezer and fridge part, and it's just kind of it's just a lie basically. So be careful how you present information to users. The interface should suggest how you interact with it. So if you look at this file cabinet kind of thing here, and you're ready to open it up, you might be like, okay, I'm going to grab the handle. That's an affordance. That a handle is something that you grab and you pull on, right? And you find that it doesn't open the drawer. You have to go into the little indented part here and pull on it to open it up. And this is actually just to help you move the whole thing around. So again, this is sort of giving a false sense of how this thing works. And you should make sure your own application sort of, shows how it should be interacted with. You push buttons, you pull on sliders, and so on. And user interfaces, again, we do this affordance thing by visual or dynamic means. So a raised button sort of implies you can push it. Something called pattern affordance, where you just get used to certain kind of things. So web pages, if they have a logo in the upper left corner, you typically can click on it to get to the home page. And when a web page doesn't have that, it's actually very frustrating to me. I'm just like, where am I supposed to go to get to that first part? So you have hidden affordances where you have to hover over to get information. Of course, that's a little trickier. And now that things have a lot of touch screens, you can't really hover as easily. And so people are rethinking that. You have to be careful about affordances. So a false affordance is basically a colored header that looks like a link, but that's a light blue color or something like that. But you can't click on it. And then again, that's frustrating. There's plenty of times I do that and I see something and I clicky and nothing happens, and it's aggravating as a user. Sometimes you can relate it to real world things. So there's a word skeuomorphism that makes the interface look like a real world counterpart. Apple was big on this for a while. They've largely abandoned it, but they had their iBooks app, and your titles looked like on a bookshelf kind of thing. Whether that was sort of a useful way or just a good way to kind of make beginners comfortable is still sort of up for debate. Mapping is very important. So people mess with controls and they want to know what is expected to change. So over here on this range top, we have 4 burners in a grid, but then we have 4 controls. And again, you'd think that maybe people would get used to it, but even on my range that is somewhat similar, I have 4 controls in the front here. I kind of have to stare at it for a while. And you can even see there's like a little tiny picture here saying which burner is being controlled. It's not a great mapping, right? You have to really kind of, even after years, I'm sort of like, oh, back burner on by accident. It's actually kind of dangerous. You can melt something or hurt yourself. This one, it's a little hard to see, but there are 5 burners in this arrangement here. And the controls have the same arrangement. So they're like a little mini map of the range. And it's much more intuitive as to what you should turn on a certain burner. So again, you want to make it clear the relationship between action and result, and mapping can help with that. Constraints are important. So most modern apps do this pretty well. So if you have already saved a file, for example, sometimes the save is grayed out because it doesn't have any meaning. You can't save a file that hasn't changed. Or if you haven't selected something, you're not allowed to crop it. Basically, you have to only the select button is viable, and the crop button doesn't work until something is selected. So don't let people try to do things that they are not possible. And that requires effort to make your user interface update itself depending on what state it's in. But it's again a useful kind of technique. Feedback is important to users. So we're used to this in the real world. Microwaves have timers. When you're in a car and you turn on your clicker, well, at least in other states, Utah, I know it's a little rare, but turn on your clicker and you see a little light and you hear a clicky sound, and so it's on. Some are kind of dangerous, right? Like little animated icons on your web page, spinning around, waiting for something to happen. And sometimes it's not actually happening. Sometimes it's just stuck somewhere. And so if the feedback is sort of a lie, that's a bad thing. If you're in a drawing program and you're trying to draw a line, it's nice to have a little rubber band showing like where the line's going to go if you release it, right? And you can kind of get it, and rather than if you click here and click here, you're kind of guessing what it's going to look like. Whereas if you see a live preview, it's nice. So these are all techniques that people have developed over the years, and they really help with the usability of applications. Okay, so to be honest, we're not really going to make such a big complicated application that many of these are that important, but I think it's always, from my point of view, it's always good to try to get some of this in your head while we have a chance. And at some point when you're doing something a little more complicated, you can kind of think about some of these principles. And I would recommend starting. This is a fine book to read. It's a nice launching pad for some of these tasks. And I think some of you are going to be sort of interested in this user experience kind of space. You're learning some coding, you're learning some art skills, production, stuff like that. And user interfaces are one area where all those come into play. So you might want to think about diving in a little deeper if you can. All right, well, let's start looking at PyQt and how that happens. So in Pygame, again, we had events. We had a game loop, and every time through the loop, we basically asked Pygame for what events had happened since we last checked, and they are in some list. We looped over the events in the list, and we used an if statement to see if it's something we cared about. So if we wanted to learn about the mouse being pressed, we'd do if the event was a mouse button down, then do some action based on that. So that works kind of well for certain kinds of applications like games, but doesn't really scale well for much more complicated applications where we don't just care about button clicks. We care about if a certain button was clicked. And also, we don't want to just have a bunch of code in one spot that handles all the interface. It makes it hard to modify the interactions between these things because it's very complicated. A bunch of if statements, if I clicked on the select button and now I'm in select mode and then I want to click on crop, then the code can get very difficult. So a different model can be helpful. And in PyQt, we also have the PyQt system looking for events. It handles like the raw interface with the computer, what's a mouse click, what's a window drag, that kind of stuff. And then the event basically generates what's called the signal. So a signal is something that a widget or the system overall emits. And basically you connect a signal to other code and you make the code run when the signal happens. So in some ways you're kind of specifying the if statements in advance. You're saying, if there's a mouse button clicked on this button, then run this code over here. And then if this button is pressed, run this code over here. And those are, you can kind of define those separately from each other, and they're not just all there in the game loop. And our job now is a little different. It's basically figuring out what the connection should be. So we're going to say, if this button's clicked, connect it to some function that does something for us. And it's a little different style than just having a game loop with a bunch of if statements in there. So let's look at an example of connecting a button and making it do some output when we click it. Right? Last time we just clicked a button and it just flashed, and it wasn't not much going on there. So let's now make it where we can control what happens when the button is pressed. So the basic approach is we're going to make a button, and we're going to take a signal from the button, and notice it's part of the button object here. And we're going to connect it to some function that we write on button clicked. Now, the problem is this looks pretty complicated right here. The button comes from us. We made it up here. The connect is a method that's part of this clicked thing, whatever it is. And the question is, how do we know about clicked? Well, you basically just kind of learn it from seeing examples. So we're going to learn some reasonable examples to help you make a user interface. And you can Google it. How do we, you search for PyQt5, how do I tell if a button's clicked? And someone will tell you, go look for this click signal. But the main thing I want you to get in your mind is the approach, right? We're going to make a connection between a button and some code, a function that we write, through this signal that is generated when the button is clicked. And this part is part of the Qt system. Okay, so let's write some code to do this. So I'm going to make this oops, I want to keep that the same. Let's bring this deck down to sort of a small size. And I need to shrink it down. We got in trouble last time, I think. Okay, so is that, can I not scoot it over a little more? No. Scoot it down a little more. Scoot that down. All right, this is. All right, we're fine. Let me bring that back. Let me scroll that over just a little bit, make it a little smaller. And I gotta shrink it just a little bit more. Okay. So over here I have a basic PYQT sort of starter code. Just to remind you what's going on, we make an application. Inside the application we make a window that's just a blank Q widget. That Q widget's going to hold other widgets by attaching it to a layout. So we make a layout that says we want the widgets to go in a vertical order. And we have to make the window know about the layout. So we have this set layout, and it basically says this is the layout I'm using. And then we're going to show the window. And then we go into the sort of game loop for event loop for the application. So if I run this, it just brings up this sort of basic, basic little widget, blank window, and knows how to do a few things. And of course, in Qt you can specify, like make it a fixed size or something like that. And I can quit it. Okay, so let's add a button. So the press me button is going to be a Q button, Q push button. I keep wanting to just make it a Q button, and it says press me. And then the press me button, I'm going to, notice there's a bunch of stuff that we know about. That this is all part of the Qt system. It's all defined. So there's a bunch of stuff you can make it do. One of which you want to do is to say when it is clicked, run the code that I'm going to connect to right here. Button clicked. That doesn't exist yet, but that's fine. But we'll get around to defining it. And then on the layout, I'm going to add the press me. And right now we only have one thing, so the layout in some ways is not that important. And maybe I will add to the layout a new button, Q push button, that does nothing, just to kind of show that I have to set up every button kind of independently of each other. So say nothing here. So we have two things in the layout, and if I run this, well, it's going to complain that I haven't defined on button clicked, so that's fine. Up here, I'm going to define on button clicked. And what should it do? Well, it can do anything, really. But what most of you can do right now is just acknowledge that the button was clicked. So I'm going to print it out to the console. Okay, so if I run this, still unhappy about something. Q has no layout, has nothing. Oh, add widget. Add widget. And add widget. And I should spell it correctly. Okay, it's happier with that. Run it. All right, so now I have this. Notice it kind of, again, sort of scales itself to the application size. If I press nothing, well, it does something that flashes, but it doesn't really do anything. If I click press me, I get text. I was clicked. So I connected together this button and an action, the clicked action, and I connected it to this function here. Now, I want you to keep in mind, connecting it does not execute it. So when I see this line of code here, it doesn't run it. So when I first ran this thing, it didn't say right away I was clicked. It's just setting up the behavior of the interface, right? It's saying make a connection between the button and some code that I don't know how to draw. So press, and this is the connect right here, right? I'm defining a relationship between these two things. When this is pressed to make this code run. I'm going to get rid of that because that was a pretty bad drawing. So it doesn't run when it first sees this line. This is just setting it up for later use. And again, a lot of the code we're going to write is basically a bunch of connect calls that say when this happens, when it's clicked, when something is changed, do this action. And it doesn't make it run. It waits for the actual action to happen here. Okay. And again, you know, it takes some time looking at examples, following along with documentation to kind of remember how to do all this stuff. Like I keep forgetting to do push here. That's fine. If I was doing this a little more in depth for a while, it would kind of get in my brain and I would be okay with it. Okay, let's try to, you know, we don't normally have applications that have a bunch of fancy buttons and stuff, and then it just dumps a bunch of text to a console. That could be a weird application. So let's connect together two Qt widgets instead. All right, it's basically the same idea. We have our signal that is generated when an event happens on one of these widgets. Something is pressed, something is changed. And then we have what's called a slot. And a slot is really just a function or a method that is what the behavior is when it receives that signal. And so some of these are pre-made by Qt for us, and then we have the option to customize them as well. And we'll get into customizing next time. So let's add in a few new things. I need a slider, which I haven't done before, and now I got to remember what a slider looks like. Is it just Q slider? Yeah, it's just Q slider. So let's make a slider. Slider is just a thing you can change a value with, right? A little slide back and forth thing. And layout.add widget slider. Let's run it and see what we have, right? Again, it's always good to run stuff and check on whether your code's working or not. Okay, we have a slider here. And it's a little hard to tell what it does. So we want to, when we change this, we want to have something else happen in our code. So I'm going to make a display, like an old style, like LCD display, a 8-segment, 7-segment, 8-segment display. And it's a QLCD number object. And I'm going to add that to the layout just so we can take a look at it. Add widget LCD. And I run it. And I get this thing down here. It's like kind of hard to see that well. So there's this thing, set minimum height on the LCD. I just want to make it a little bigger so like the actual numbers are a little more like bolded. Set minimum height. I don't know. Oh, there it is. Okay, I thought it had gone away for a minute. And I'm gonna make it big, like 60. And I'm guessing those are like pixels. I don't really know what that size number is. So we'll hope for the best. Okay, it's a little better. Still, I think there's other things you can control, like how filled that is, how wide the segments are and stuff like that. But at least we can see it. So here I have a slider. Here something that displays a number, and the natural thing perhaps is to want to connect those two together. So that's the thing that's really easy to do in PyQt because it's all built in. You just have to say, I want this to control this. So we're going to do that by, for this slider, use a value changed signal. And again, how do you know that? You got to see it once, go back, look at examples. You just have to either Google it or learn it somehow, right? It's a big system, it has a lot of stuff, and it's worth just spending some time looking at some of the documentation. Like if you go search for QSlider, somewhere online it'll say, here's all the things it can do as signals. And you go, okay, that's sort of useful. And I'm going to connect it to the LCD object. And it has a built-in function, a slot, called display. Right? I didn't have to write this myself. It was already there. That's great. I didn't want to write it. I just want to use it. And that's basically it. So really, I have two things, a slider and a thing to display some sort of number. And then I take one line of code and I can connect those two things together. And now, right, so first of all, we learned that the slider by default goes from 0 to 99. You can change that. You can change how much it skips and stuff like that. But kind of with one line of code, I can connect together these two powerful pre-built objects, these two widget components, and make them sort of do what I want. I want to have something here that controls the number shown here. And eventually, maybe that number is telling you your system to do something else, play something back at a different speed or something like that, right? So we can grab those values out of there. So that's where Qt starts to look really pretty nice, is that it has a lot of built-in stuff, and our job is just to kind of learn what's possible and then learn a little bit about how to do it, but it only takes a little bit of code to make it happen. And I think that's where your skills are good, because you have the Python experience to make those two, build those objects up and connect them, and then you can make a fairly reasonable interface just doing that kind of stuff. All right, so that's it for now. Soon we're going to learn how to sort of make our own custom widgets that sort of do our own behaviors as opposed to what's built in. And in the lab tomorrow, we'll play a little more with this kind of signal slot and connect stuff to hopefully get you a little more used to it. All right, so that's where we're at. Bye. And I need to stop this.